Hello guys, my name is Multimeter and my partner is Elen. Our group is Elen 43 and we have designed, built and tested a working multimeter. So our multimeter is composed of two key components. It measures both voltage and current. So it's a voltmeter and an ammeter at the same time. So I'll be covering like the voltmeter part. So the way that we design our voltmeter, we use thin long wires because they have a very high resistance, right? And we also felt the need to connect a shunt resistor of 150 kilo, 150,000 ohms, so that it actually absorbs the most current, right? And we connected it parallel to the actual circuit. So I'm going to be demonstrating how this voltmeter actually works. The voltmeter range is between 0 and 30 volts. So we've actually connected like a circuit to the power supply. So basically I'm now going to be demonstrating how this voltmeter actually corresponds to what is happening on the actual analog multimeter. So now our voltage is at 10 volts. Now we are going to 20 volts, and the maximum voltage we can actually measure is 30 volts, as it is actually visible here on the analog multimeter. So this shows how accurate our system actually is. Thank you.
We chose to use the thicker wires to do our ammeter part, since the thick wires has low resistance compared to the thin one, and again it is short in length compared to this one. And we even cut the wire into 2 equal parts and then connected them in parallel, as you can see here, to reduce the resistance even further, so that the current that passes through becomes almost entirely passive when it goes through the meter. Here we short-circuited the meter to the voltage supply here, which can also read the current here, so that we can demonstrate how this thing works. So as you can see here, when I turn the voltage, the current reads 3 amps with only a voltage which is around 0.4 volts, which is very low. So this shows that the meter is almost passive, and though we couldn't reach the required burden voltage, but it can show that the meter is almost passive, and it is accurate in reading currents in seconds. So